Number 52, a 25 ml sample of a 1 molarity solution of acid 1, so acid 1. And if you guys remember from the previous questions, this acid 1 was the weakest acid among all these guys. So let's just kind of mark that. Weakest acids. Is mixed with 25 ml of 0.5 molarity, half of the NaOH. Which of the following best explains what happens to the pH of the mixture when a few drops of 1 molarity of HNO3 are added? Nitric acid, strong acid. So you would expect the pH to go down because you're adding strong acid, becoming more acidic. So it's got to go down in its pH. And that's absolutely not what happens, because if you guys understand the purpose of this question is basically talking about the concept of buffer, right? What do we have? We have this weak acid. I don't know what that acid is, so I'm just going to call that HA, right? Well, and it's going to dissociate into H plus and A minus. How well? Not so well, because once again, this is a very weak acid. But check this out. You have the same volume, but literally half the molarity of the acid. So this is what's going to happen. If you were to have like, 100 here and nothing here, I'm just basically doing all these charts. Now, once again, it's probably not 100. Like, you can use the actual number if you would like, but I'm just giving you some ideas. What's going to happen? Well, you have exactly half the concentration of the strong base, so that's going to take away half of your acid. So you're only going to have 50 left in terms of your acid, and obviously since you're losing that acid, that just means they're being dissociated into H plus and A minus separately. So you got 50 and 50, of which this H plus is going to be consumed by the hydroxides coming off of the sodium hydroxide. So all you got left is just basically the original acid, 50 of them, and the conjugate base, 50 of them. You have the same exact amount of your original acid and your conjugate base, meaning you have the buffer, right? So since you have buffer, I don't care if you're, dropping freaking a strong base or strong acid, the pH will not be altered by a significant amount, right? So what's going to be the answer? Well, increases sharply? Absolutely not. It's not going to change, right? Stays about the same, stays about the same. What's the reason behind it? Well, C says because the conjugate base of the acid won't react with the H3O, the hydronium ions. Absolutely. In fact, that's how the buffer mechanism works, right? If you throw in the nitric acid and therefore all these hydroniums are now floating around, well, what's going to happen is this conjugate base is going to take up all of these guys, just literally consume them up, and then become HA. Well, and then some people might go, well, but that's also an acid. Well, yeah, it's an acid, but that's a weak acid. What's the chance that it's going to dissociate back into H plus again? Not quite, right? Because once again, it doesn't dissociate very well. It's a weak acid. So that's the mechanism through which the buffer works, right? So that's absolutely true. So look at what D says. pH of the mixture stays about the same because the hydroxide ions in the solution react with... No. That's not what's going on. The conjugate base is what reacts with the incoming hydronium. So the answer is going to be C.